The moving sofa problem is one of the most important unsolved problems in mathematics. Originally posed in 1966 by mathematician Leo Moser, the problem asks, what's the largest two-dimensional shape you can move through this L-shaped hallway that has a width of 1 unit? So let's start by moving this square sofa through the hallway. It has an area of 1, but surely we can do better than this. Well, how about this semicircle with a radius of 1? It has an area of approximately 1.57, and it looks way cooler pivoting its way through the hallway. The first big leap in the moving sofa problem came about in 1968 when the mathematician John Hammersley introduced this shape to the hallway. The Hammersley sofa takes that semicircle, adds a rectangular block to the middle of it, and chops a littler semicircle out of the middle of that rectangular block. It has an area of approximately 2.2074 and kinda looks like an actual sofa or a telephone, and that's just really satisfying right there. Hammersley sofa reigned supreme until 1994 when the mathematician Joseph Gerver introduced this beauty to the mathosphere. It looks almost the same as the last Sofa King, but this one actually has 3 straight line segments and 15 different curved segments with different curves in it. The Gerver sofa has an area of 2.2195, and would you just look at that? Dang. There's some evidence that this is the largest sofa that could possibly make it through the hallway, but it hasn't been proven mathematically. But all of those couches can only turn one direction down the hallway. If you had to make a left turn further down the hallway, you'd be screwed. Surprisingly, if you have to turn both ways down the hallway, this shape is the least likely to get plugged up. The Romic ambidextrous sofa was figured out in 2018 by mathematician Dan Romic, who was on Numberphile and whose website I got these animations from. So now that you know, I'm sure you'll agree that